Good afternoon, everyone. This is Marian.
Hello, Jackie Chong again. Greetings to foreign bodies around the world and all Chinese friends. Hope all of you are nothing wrong with the COVID-19 virus.
Today, we're going to present you a LiDAR survey job case from field to office. Due to the time limit and the rainy season, we have recorded the field work part. After that, we will show you how we handle the data. Shall we begin now, Jackie?
Why not? So 1 to 500 topography with UAV-based LiDAR survey. Let's go video.
Hello, Jackie.
Hi, Maureen.
Yeah.
Welcome to the site.
Yeah.
Hey, say hello to Maureen.
Hi. How are you doing?
Just fine.
Okay.
So you are coming for the global live show videography, right?
Yeah. You know, our survey live show is very hot in China, and we would like to see how our Z-Lab team accomplished a LiDAR survey job. Would you please introduce something about this mission?
Sure. Well, it's 1 to 500 topography survey work for rural roadway development.
Okay.
We are now situated in Zhengcheng district, Guangzhou. And the survey zone is between two local villages here, Dengshan Cun and Xunai Cun. The two villages are actually 4 kilometers away in linear distance.
Yeah.
But there's no direct roadway in between. So the villagers have to travel a very long way by taking a very big U-turn like this to meet each other. You know, it takes almost 1 hour, even more than that, by car. Oh my God, too long time for the 4 kilometers. I mean.
But how did you know it will take 1 hour or even longer time for that U-turn?
You know, this is flight number 2. We got flight number 1 in the other part of the zone, actually in the other village I mentioned before. Here, the local government decided to develop country roads to make shortcuts for the villagers. Okay, yeah. You see here, the vertical height drop is more than 100 meters in such a small area. Just 23 hectares. But you see here, elevated and vegetated.
Okay.
So we got the job and confirmed with the employer about our technical proposal. Now we're here.
Oh, what's that about?
It's our workmate.
Okay.
It's a UAV-based LiDAR system.
Okay.
This time we use a R1350 light. Look, this is scanner part. And in the back we have IMU and GPS modules inside. The scanner measures 500,000 scans per second, and its maximum measuring range is 1,350 meters. A very powerful one. I mean, the measuring accuracy is 5 to 10 millimeters. A very powerful one with a single beam, multi-echo technology, and remarkable measuring range, right? And then the GPS and IMU module will help us to record aerial positioning information, as well as the mobile carrier's orientations of the UAV mobile carrier, right? Orientations like pitch, roll, and heading. And of course, different levels of IMU will provide different grades of accuracy, right? That's why we better find high quality IMU to match this high precision scanner. When all these 3 sensors are integrated into a LiDAR system, I mean like this one, we can expect the laser point cloud accuracy around 10 centimeter at 300 meter flight altitude. The other sensor will be the camera. Sometimes inbuilt, sometimes attached.
Yes.
Okay. Normally we use a smaller LiDAR, R250. R250. Yeah. But this time we use the bigger size one with another hexacopter.
Yeah.
Also, the drone is bigger, right? With this drone, we can carry the bigger size LiDAR and fly around 45 minutes.
Oh, excellent.
So we can enjoy longer endurance, bigger coverage, and higher efficiency.
Okay.
Yeah.
So is this model carried with other career performance platforms?
Yeah. Now it goes with multi-rotor, and it can be also working with VTOL fixed wing.
Yeah.
Right, and then still manned aircraft like helicopter.
Yeah.
Then number 4, SUV-based automobile mode is possible too.
Okay.
Yeah. Okay, let's keep away.
Okay.
I think it's almost ready to fly.
Whoa.
Okay, keep away. Just get here.
Okay. Woo.
ATL above ground level will be 250 meters.
Yeah.
With flight number 2, we can capture all of the area.
Oh, okay. Yeah. So, like our slogan, fly or drive, map 3D map.
You're right.
Okay.
You know it.
And many people want to know the output accuracy. So, what's your idea about it?
It's a good question.
Yeah.
Yeah. Well, first of all, the precision and accuracy of the laser scanner should count.
Yeah.
With the Regal single beam survey grade sensor, we can expect 1 centimeter in accuracy. And then the IMU, the quality of IMU and GPS module, and the system integration are very important. The integration techniques will lead to some system errors, more or less. Yeah, then affect the output accuracy. Yeah, that's why the system calibration by the factory is a must. Still, the fly altitude, the fly heights result in the scanning range, scanning distance. The lower you fly, right?
Yeah.
And then the shorter distance it scans, and then the better accuracy we can expect.
Yes.
Yeah. In China, we have our national, standards or say specifications for different mapping scales. Against 1 to 500, there should be at least 16 points per square meter. And then for 1 to 1000 scale, there should be at least 4 points per square meter.
I see.
So it depends. Here you see the convex terrain here, right?
Yeah.
Elevated and vegetated. Everybody knows that it's hard to obtain a high pond density in such an area. I think it's also difficult for other survey methodologies, right? Pond density is another critical one. The more true and accurate ground points we can collect, the better ground surface we can reconstruct. And then finally, the manual intervention in the post-processing, like point cloud classification and vectorized mapping, will inevitably cause further errors. So experience means a lot more in this section. Yeah.
Okay.
Well, back to the topic. Basically speaking, the output accuracy of LiDAR survey is closely related to all the 5 factors mentioned before. Yeah. And normally we say LiDAR survey brings us centimeter level accuracy. Sometimes 5 to 10, and sometimes 10 to 20, or even lower, depends. So we have to see case to case. Yeah. But when you expect, when you expect both accuracy and efficiency, I think LiDAR would be a very good option.
Yeah, yes.
Oh, Jackie, are you okay? Okay. Sorry. Ah, terrible. Sorry. So, let's say sizable area,
Yeah.
difficult terrain, and then accurate data. Go fast. No better option but LiDAR.
Oh, fantastic. Seems that LiDAR is very powerful in the survey work. So, do you think LiDAR is the best equipment in geospatial industry nowadays?
Fantastico.
Yeah.
It's a funny question, Marine. I like it. According to me, there's no the best equipment in the
Yeah.
absolute sense, but there is always the best solution to a specific case. So when the most cost-effective solution
Yeah.
can balance your time, balance your cost, and satisfy all the job needs, we'll say it's the best solution for this job, a
Yeah.
particular job. Okay, you know, upon a new survey job, we need to look into several issues.
Yes.
Yeah, before we go, or before we do the job, right? Such as let's say accuracy expectation,
Yeah.
output demand, and then submission deadline, and yeah, terrain conditions, of course,
Sure.
and blah 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 blah. Look, the drone is passing overhead, and the LiDAR is capturing data in its mission. Some survey jobs will be in the city,
Yeah.
in the town.
Yes.
Most probably, you take total station or RTK or terrestrial laser scanner or other equipment, because you can access to most of the places you wish, right?
Yeah.
But what if you are going to challenge those inaccessible areas with dense vegetations, right? In the high mountains and hills, this and that, right? It's terrible, not easy, right? And your clients always call and push, quick result, quick data,
Yeah.
right?
Yes.
And still they demand highly accurate DEM, contours, vectorized map, and even offer photo. What will you do? What do you think? It's not easy. So, no better option but LiDAR, I think.
Yes. Yes.
Uh-huh.
Yeah. You're right.
When we got this job case, you see the complex terrain here, right? It's hard to climb the mountain. Just now I even slipped, right?
Yes.
Yeah. It's hard to go inside the forest to do the work, and then it's hard to obtain RTK fixed solutions under the dense canopies. Here is bare, it's easy, but would you like to climb up, right?
No.
It's hard to collect sufficient data against 1 to 500 mapping scale.
Obviously.
Yeah.
Yeah.
Wow, not easy, man. And then, so when you take a job like this, yeah, easy job not for you, right? Difficult job, 어떡해 친구야. So no better option but LiDAR. You know, the laser scans, I mean from the LiDAR, from the laser scanner. The laser scans help us to penetrate between the gaps of the gaps between tree branches and leaves,
Yeah.
and then reach the ground and obtain the ground points data,
Good.
true and accurate.
Oh, excellent.
And then, you know, just in a single day, right? We came this morning,
Yeah.
right? We came this morning. one fly there, one fly here. We almost finished. We finished the data capture, right?
Yeah.
In my word, short but sharp.
Yeah.
I mean, short time,
Yeah.
but sharp data.
Yes. Yes.
Hey.
You're right.
Can you imagine? Can you imagine how long it will take to do ground survey in the forest with RDK? Can you? Much longer, I'm sure.
Yeah. You're right. You're right. With LiDAR systems, we are able to deal with more challenging work. It's very efficient. And but what if I mean buyer's team cannot handle the hardware operations or software processing even after the training program?
Yeah, my understand.
Oh, thank you. And I mean, it's not easy to learn or remember all. And it's common to everyone, right? So, what do you think?
I can't agree more. Yeah, it's not easy to learn at the beginning.
Yeah.
Actually, that was one of the most frequently asked questions from our clients. You know, when we manage capture massive data
Yeah.
from fieldwork, right? And do much faster compared with ground survey.
Yes.
I think we do need some time, right? We do need some time in the post-processing, right? And I believe it's a fair game, isn't it?
Yeah.
Yeah. LiDAR using remote sensing technology, unlike ground survey, measuring point by point, right? LiDAR using remote sensing technology collects trillions or even zillions of points all together.
Wow.
Yeah. Big number. So all those points, what to, how to. Some points are wanted,
Yeah.
like the ground points,
Yes.
but some are not, like the vegetation or buildings, right? So we have to classify the point cloud and remove all those unwanted points, right? That represent the ground objects, right? Like the cars, yeah, it's moving one, right? It doesn't represent the earth.
Yes.
And some points represent the trees, vegetations, and those buildings, right? After we remove all of them, and then we can generate the highly accurate DM and contours, right? On the other hand, the lasergrammetry vectorized mapping is a bit labor intensive.
Yes.
Yeah, and I'm sure you need some time. You need to learn. You have to learn and spend some time on it, right? Invest some time in it. Yeah, maybe some beginners will feel it difficult, hesitant to buy. Yeah, they say, wow, your workflow includes several steps. Several steps, this and that. How come? How to? Okay, right? Quite some buyers think like this, and they show us their worries. You know what we did? You know what we did? You know?
Show me, please.
Since we have plenty of survey jobs here and there, home and abroad, right? We would invite our clients to the sites.
Yeah.
Maybe in China or maybe overseas. It depends on the distance and depends on the schedule. We'll get them into our actual LiDAR survey work, right? Going with our experienced fieldwork team, they may easily understand more about how to challenge different terrains and conduct the entire workflow with us, right? And suppose they could stay a bit longer with us. We may even guide them. We may even guide them and show them how to process the data and generate the results as desired by the employer, right? No simulation, no simulation, but all reality, 100% hardcore.
Good.
So, is it more practical for them to learn? What do you think?
Yes, it's a good idea, feasible and practical, as we do have plenty of survey services running in the year. Another thing, most of people are interested to know how to verify your output accuracy and prove your results for acceptance.
Good question again, Marianne. You know, in principle, you just use an old methodology to verify the results from the new, like what we did a couple of years ago, using total station to check GPS results. Look, you know?
Yeah, I see.
What they are doing about?
One of them is doing article survey, and the other is taking pictures. I remember one told me that we don't need any ground control points in LiDAR survey, but why your team doing such measurements point by point?
Correct. They are doing article survey point by point. Yes, but such measurements are mainly considered as checkpoints in our workflow. In other words, they are not gonna be used as type points and improving the final output accuracy in the way of photogrammetry. So we just use them to compare in our laser point cloud. As long as the laser point cloud is okay, no problem, accurate enough, so we may expect very nice output, because all the outputs will come from the raw data. Raw data is the fundamental of all upcoming approaches. For your information, we managed to achieve the accuracy expectation and satisfy the job needs in the past few years from our jobs. A lot.
Okay. Could you please tell me more about the past job cases, Jackie?
Okay. You know, China is our home market.
Yeah.
Right? So we receive survey service inquiries from time to time here.
Yes.
And you know, South Group is trying every best to transform from a survey equipment manufacturer and a GIS solution provider to a geospatial data engineering and application specialist. Apart from the routine operations in China, we also got some survey jobs in the foreign countries like Cambodia, Malaysia, Indonesia, Myanmar, in Asia. And then also some in Africa like Cameroon, Benin, blah 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 blah. So we are proud of our field proven solutions and project based learnings. Well, you know, such LiDAR survey jobs include topography, cadastre, power lines management, forestry investigation, roads scanning for SBU survey or asset inventory, and blah 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 blah. Plenty more. Come on.
Jackie, you're quite an expert in LiDAR survey now.
Not really, but thank you, Marine. But I'm sure we have so many experts in the Z-Lab team. They know much more than I do. You know why? Because they're always in honeymoon.
Honeymoon.
Yeah, honeymoon. Honeymoon with a number of product studies and deep applications. I mean, site knowledge and project experience, job experience, right? Site knowledge and job experience help much better in the actual survey work. compare with the goddamn textbooks or user manuals, I suppose.
I believe our Z-Lab team did a very good job. Practice makes perfect, and time will tell.
Yeah, exactly. I can't agree more. You know, Rome was not built in a day, right? Not about the epidemic. And the existing team building from us results from years of continuous hard work. Thanks to the top management, thanks to the support from our top management and also the support from our dear clients, we got so many opportunities to practice, to learn and see. So you came late, we almost call it a day.
Yeah, what a pity. I came so late and it's already the end of the job. I have a question. How long will it take for our Z-Lab team to submit all the deliverables?
Deliverables.
Yeah.
That's the key. You see here, 23 hectares, almost 90% vegetational cover. I mean, we don't have a lot of ground objects to vectorize and put into the map. According to my experience, our colleagues need maximum 2 days for the point cloud classification, DEM generation, and orthophoto map production. Still, they need another 2 days for the vectorized mapping. Those small size, quite a few ground features to be presented and vectorized against 1 to 500 mapping scale, right? Let's say also 1 day here. So in total, within 4 to 5 days, we can complete all. That's
bravo! One more question. Many clients even asked me before whether we could provide data processing service individually.
So you mean, excuse me.
It's okay.
喂，对，我们在现场，差不多搞定了，放心，可以的，没问题。好 ，OK， 拜拜。It's from the client.
Pushing you, all right. Okay. The question is provide the data processing service. Yeah.
Okay. Yeah. So my answer is yes, possible. Actually, we started this type of service before.
Okay.
Some of our colleagues used to work in the professional data processing service companies committed to laser point cloud applications for quite long. Some of them with 10 years and some of them even nearly 20 years. So I'm sure we got a very capable team to handle the data. In my word, our colleagues are really side genius and data monsters, you know.
Yeah, funny words, side genius and data monsters. Another side?
Yeah. Let's see. Come and have a look.
Okay.
This is our R250, a smaller LiDAR with M600 DJI matrix.
Okay.
Usually we call it a star LiDAR solution. We take 2 sets here, one for standard capture, another set for backup or practice. Okay. Suppose the area size is small, we will capture two groups of data. And then we compare the accuracy, we compare the efficiency, right? Sometimes fly high or low, depends, right? This is the way how we improve our, let's say, how we improve our workflow or teamwork. Okay.
Hey Jackie, here please.
Okay, let's see something new. Hey, Marine, look. This is the point cloud we generated from the first flight. There we also got some GCPs there. Let's see. Next piece. Okay, GCP here.
What for?
What for, right? We import the GCP into the software and then we can generate the control report. From the control report, we can tell the deviations between laser point cloud and ground survey by RTK. So
I think this is okay.
see, below 5 centimeters,
Oh,
Yeah.
It's okay.
excellent. Yeah. Okay, thank you, Jackie. Thank you for your abundant information. I think I've learned a lot today.
Yeah, welcome, Marine.
Yeah.
I hope you enjoy your day.
Yeah.
Our Z-Lab team is always standby and ready to help.
Yeah.
But now we are ready to go home lah. Let's go back and see how to process the data.
Okay.
Right? Sayonara, camera.
See you soon, my friends.
Welcome back. We are now indoors. Because of the rain and the time limit, we just recorded the fieldwork part.
So it's time to process the data, right?
Bingo. Here we go. Please pay attention to the top. That's the complete workflow, like a progress bar, right? From left to right. Welcome back. We are now indoors. Because of the rain and the time limit, we just recorded the fieldwork part.
So it's time to process the data, right?
Bingo. Here we go. Please pay attention to the top. That's the complete workflow, like a progress bar, right? From left to right, 1 to 8 steps in total, roughly speaking. And below, that's the background information of the survey job. Hey guys, I'm not going to read everything on the slides because I'm sure you are smart enough to understand all my literatures easily. Instead, I would like to tell you something behind for more hidden messages. Okay? On our side, first of all, the processing team need to have a general idea of the job information. Let's say, to study this and that document, to be sure of the employer's requirements, right? And also communicate with the fieldwork teams about their side stories as well. For example, the processing team will advise the fieldwork guys about reasonable flight heights against different terrains based on their point density output experience. The box here shows their side tips, side notes, like bookkeeping.
Okay, I have a question. It's not always to have the same team to capture the data and then process, yes or no?
Yes, for higher work efficiency, we will split the job into 2 parts, fieldwork and processing. Yeah, in that case, each team could be more specialized and just focus on what they're really good at. Now we collect the raw data. Let's see, 1, 2, 3, 4, 5, right? The raw data from the fieldwork team, and then continue right here.
Okay.
And of course, there will be a long list for all the necessary materials, like here, and those mentioned in the previous slide. Then the processing team may follow up properly.
Wow, it comes with quite a lot of raw data and seems complicated.
Come on, Marian, you're just a beginner right now, right? When you get started, your experience will tell how it works. Here are the procedures of data production. We just need to follow the requirements by the employer and submit what they need, right? Not all.
Yeah, but that's quite a lot indeed. But different clients may have different demands, not all as always.
Yeah, not all as always. Let's put it in a simple way. You need more, we do more. And then you pay more, you get more. Yeah, that's it. Deal.
Yes.
Well, next, it will be the trajectory data processing. Since we have Novatel IMU inside the LiDAR, we will use software from Novatel, Inertial Explorer. See here, we collect IMU data and GPS data from the LiDAR, and then download the base observations from the ground base or coast station. Then we do PPK processing, computation. Then we will have the trajectory data post file, positioning and orientation system file. Yeah, that's it. And then we go ahead for the point cloud generation.
Okay, this software is developed by our company, right?
Yeah, we call it Z-Lab point process.
Okay.
We can generate geo-reference point cloud and colorized point cloud in it. For these two steps, I mean trajectory data processing and point cloud generation. Usually it takes 10 to 15 minutes for each flight, I mean. Yeah, not too long.
Okay.
ZLab,
Yeah.
point process.
Yes.
After that, we have to verify the data quality. And there are 4 major criteria listed here. 1, 2, 3, 4, right? Like drone mapping, we have to see whether the capture data has covered the entire mission zone or not. And then in the section display on the left, right, no stratified point cloud. In other words, no double rooftops, and no double ground surfaces. Then accuracy level in the middle, right? It's below 10 centimeter. I think it's okay.
Yeah.
On the right, point density. Now we have 60 points per square meter, more than enough.
Yeah.
Right?
But what if the data quality is not good and might not satisfy the mapping scale requirements, yet the field work team has left the site? What will you do?
You got the point, Marine.
Yeah.
Question go, Marine. It's a very typical question to the project manager.
Yes.
In our way, we will get our fieldwork team to process the trajectory and point cloud themselves, right? As mentioned before, these 2 steps would not take long. So they will check all such 4 items, 1, 2, 3, 4, on the site. Otherwise, it's hard for them to go back and repeat. Yeah, and the processing team will just start with the generated point cloud and go straight. Yeah, everything okay? We move on.
Yeah.
Now, with the geo-reference point cloud, we have to work on the classification.
You mean to classify the point cloud into different classes, wanted and unwanted, right?
Exactly. For the initial classification, the essence is about macro algorithm. Macro algorithm, not macro, okay? For batch processing. Our colleagues will apply different algorithms for different terrains and different tree heights, like forest, jungle, bushes, etc. Yeah, better algorithm will save considerable efforts in the following steps. Go ahead. We will work on the auto mosaic that would be used as reference to tell ground objects more easily. And the 3.5 centimeter GSD here, see, right? It's good enough for our coming 5 centimeter resolution of a photo map production.
It's for this mission.
Yep, for this mission, of course.
Good.
Next, we will come to the intensive point cloud classification. The algorithm computation could not tell the points correctly. So we need to do something manually, by manual efforts, right? That's to restore those wrongly classified points back to what they are supposed to be and remove all those remaining ground object points from the ground class, right? Something like plus or minus.
I heard before it's a bit labor intensive. How could we do it faster then?
Well, besides appropriate algorithm, we need some techniques like deep understandings about software display and the actual environment. See here, we need to remove those points that do not belong to the ground, right? Let's say example 1 and 2. The noise points, the building points, they do not belong to the ground. So we have to pick out and remove, right? And then example 3, bridge. How about the bridge? Do you think the bridge belongs to the ground, represent the ground or not?
Yes.
Yes? Oh, sorry, wrong answer this time. The bridge is actually an architecture, a building, right? So we have to remove also. Then, on the other hand, we need to restore those points wrongly put into other classes, the scarp points and the mounting body points, right? We need to restore and keep them there. Yeah, so before and after, look here, look here, right? Those 5 pictures shows the correct examples. Little by little, part by part, we may recover what they should be. And then we may expect to obtain better digital terrain model and better digital elevation model. Yep.
Okay. But what if we overlook or ignore some parts in this step?
Overlook.
Yeah.
That's why sometimes we refer to the image of a photo to see what they are in reality. Look, yeah. Example 6789, yeah. Water resources, road shoulders and ridges, they belong to the ground, right? We cannot remove. We have to keep.
Yeah.
Yep. And then the vegetation or debris points, we must remove. Then you see the flat ground surface here.
Yes.
Yeah. Also, before and after, the pictures below show the correct examples. For sure, our processing team will have a double check by a more experienced guy. Let's say by the team leader. You remember Ms. Wang Xiaoli, who presented in Chinese language last Friday morning.
Yeah, Engineer Wang.
However, it's manual work. Yeah, we could not guarantee, we could not say 100% correct. Yeah, but we must pay full attention to the job. And I'm sure our teamwork, our team knowledge is good enough to tell what is correct or not.
Yes, you're right. Teamwork is the key.
And here we have the digital surface model. In order to show it more clearly, our colleagues put it to 0.2 meter resolution instead of 0.5 meter resolution. Now you may find some vegetations, buildings, right? Quite a lot on the ground surface, right? We say it digital surface model with all the ground objects on the surface, right?
Yes.
Then, based on the efforts of intensive classification, most of the ground points would be kept in the point cloud and for generating the digital elevation model, like this. See, all the ground objects were removed, and we got only the bare earth surface there. See, like this.
Yeah.
It's from my hand. Now it's bare. But still one more.
And that's one of the major outputs in topography.
Yeah, DEM is very critical.
Yes, yes. Okay.
Next, contour lines, as requested, 50 centimeter interval. We may say it quite precise because we got sufficient ground points, and the micro expression of the ground surface is perfect. Perfecto, you know?
But it looks not too smooth.
But that's accurate in depth, you know. It depends. For engineering and design works, the clients, civil engineers, prefer more accurate data, so we would keep it like that. But suppose it's used for final output or documentation, we would probably do some more fine editing in CAD software.
Okay.
Yep. And next, offer photo map.
It's T-photo in TerraSolid.
Yes, we could make full use of the modules, all modules in TerraSolid. It's a very powerful software kit for point cloud applications. You know, some feature points in the point cloud will serve as type points in photogrammetry, and it saves our efforts in GCP matching.
Got you. By the way, can we use Sky Photo or other photogrammetry software?
Sky Photo is from us.
Yes.
Yeah.
Okay.
My answer is definitely yes. Sky Photo, Pix4D or PhotoScan will do. However, in lasergrammetry, orthophoto is usually considered as a byproduct, not the major one.
Yeah. Okay.
Well, it comes to the last but not least part, my friend, vectorized mapping. We need to work with ZLab Mapper and CASE, a CAD platform software kit for different vectorizations. We may vectorize the terrain features based on DSM and DEM, like the ridges, box, bumps, etc. And then we can vectorize the houses, roads, fences, bridges in the point cloud instead. Right? We can even tell the terrestrial boundaries, like farms, houses, whatever, pipes with both DOM and point cloud. Yeah. The vectorized mapping can be split into several teams, different production lines, just to increase the efficiency. With the help of different software kits, the mapping could be easier. For instance, the roadside points, okay, might be blocked in DOM because of the trees. Yeah, and we can find them in the point cloud and DEM.
Okay. Because
laser scans can penetrate the gaps between the tree branches and leaves. So it's just like the sunlight.
Yeah, the sunlight.
The laser scans can reach the ground, and then we can get some ground points there. So we can vectorize with the point cloud instead of DOM only. Point cloud plus DEM instead of DOM only. Yeah. And sometimes we will refer to the DOM, the image, of a photo, the image, to see what the ground objects are. There might be some fallen trees. The trees fell down and then they lie down on the ground, right?
Yeah.
Fallen trees, though lying on the ground, but they do not belong to the ground, right? They are actually, we say, trashes or garbage, right? So in vectorized mapping, we cannot put it there. We cannot vectorize them as vegetation, right? So in one word, we need all such kits to do our job. Yeah. Zilla Mapper is developed by Sao, another software kit from us. Users may vectorize points, lines, polygons in the 2D way and refer to the left window and vectorize in the right one. Yeah, the operation will be interactive as it's double screen linkage. For example, we refer to the DSM and vectorize the house in the point cloud. And on the right, we make a cross section. Yeah. So rooftop here, cross section. For the houses, then vectorize the boundaries.
Yes.
But in photogrammetry, it's hard. The house eaves, the extruding rooftops, will affect our evaluation and block our vision, Yeah, mostly we will even do some site research like total station or RTK survey for the precise house boundaries, right? But now in lasergrammetry, this part could be really easier.
Okay. For this page, why the point cloud here is displayed in gray color?
Actually, the point cloud could be displayed in many modes, in different modes. By class, by flat line, by elevation, by shading, or whatever.
Okay.
Here, it's displayed by intensity, and it would be easier to tell the row lines. Display mode option is the magic to show more 3D information with the point cloud. Okay.
I got you.
Then we will vectorize the scarps ridges in software case, a very popular and powerful topographic and cadastral software kit in China, mapping software kit. Yeah, up to now 20 years of dominance in the market.
Case.
Yep. We may enjoy the feature library with abundant options like a variety of road types, highway, right? And then country road, a city road, or small lanes path, right? You have a lot of options. And also we have a variety of house types, blah, blah, blah. I'm sure all surveyors and civil engineers in China know about this software very, very well. Yeah, CASE, CSS, Computer-Aided Surveying System. And also, contours could be edited here. Maybe for international market, users can do the same in other city or microstation platform software because the data formats are compatible. Yeah, and after an overall check, the deliverables might be ready. For your information, the data process of SUV base, aircraft base, I mean helicopter base or manned aircraft, and even other platforms is more or less the same. The data processing more or less the same. Okay.
Whoa. Okay, for this page, here is the complete workflow from field to office, right?
Yes.
Okay.
I guess everybody could understand better from this simple chart for quick review. Many efforts are involved, but once you experience and practice more, the learning curve is just a matter of time, my friend. Don't worry about it.
Okay.
And next, we'll show you some typical job cases we did before. First one, 1 to 2000 topography for a large infrastructure, wind power station engineering, Inner Mongolia, China, right? 763 square kilometers.
Oh.
We accomplished the whole job within 30 days. 30 days. Much faster than expected by the employer.
Yeah.
They put it to us 45 days, but we did it with only 30 days.
Yeah.
Come on.
Helicopter based.
Yep, helicopter based. Second one is about a project of hydropower station development in Cameroon, Africa. There we did both topography and hydrography with full gear of South solutions. UAV, see, right? And then LiDAR, and then USV, unmanned boat, the same model that Bing just showed us last Friday. Actually, the deliverables could be done within 1 week, but in practice, it took 20 days.
What happened at that time?
Nothing wrong, but the poor internet transfer. You know, power station site is always far away from downtown, right? And our fieldwork guys suffer too much for the data transfer back to the processing team, back to the office. But that's reality. You have to face, you have to challenge, you have to do it.
Okay.
That was the story.
Okay.
Well, next, laser scanning for power lines inspection and management due to strong interference. Yeah, I mean, strong electromagnetic interference. It was not good for the UAV base. So we did it with helicopter base again. And the output now is different from our routine topography. Yeah, see it?
Yeah.
It's power lines analysis report.
Yeah.
We can tell the damage or damaged wires or damaged parts in the facilities.
Yes, I can see power lines clearly in red ones, yes.
Yeah.
Okay.
Different type, different outputs from our topography.
Yes.
Right. Then we have another topography job for 50 kilometer, sorry, highway development. Within 2 hours, just 2 hours, we accomplished the data capture.
Wow, speedy act. So that's a VTOL fixed wing, right?
Yep, a large size one. Longer endurance, 4 to 6 hours. Gasoline type, not battery type. As you see, we put our LiDAR R1350 light inside the compartment here in the front, right? And we did it with incredibly high efficiency in both fieldwork and processing. Fieldwork quick and processing also fast, right? Only 3-4 days, we completed all for these 50 kilometers. Come on.
Marvelous. I remember aircraft rental service is not available in some countries according to our clients. So this VTOL fixed wing with long endurance is pretty good to carry the long range LiDAR.
Yeah, you got the point again. Question Girl Marine is a smart girl indeed. Yeah, with the VTOL, longer endurance, we can avoid the troubles, right? In some countries, we don't have the aircraft rental, right? What shall we do? So we need better, longer drones to fly longer, right? And then the next job is about your SUV-based automobile laser scanning. Yeah, that time the client requested 3 centimeter in elevation. just to compare with the S-build survey data. And then we had to adjust the trajectory correction by some ground control points for high accuracy output. See the picture in the middle?
Yeah, it's GCP.
Yeah, GCP. We need them for correcting the trajectory. Why? You know why? See the pictures, see the photo, and also the point cloud, right? We encounter plenty of tree blocks in most part of the road. So GPS signals were not good, and then the trajectory was affected. We need the GCP and then correct it for much higher accuracy. Yeah, that's it. And the last one here, power grid engineering topography in Indonesia. I was one of the team there during the Lunar Chinese New Year 2 months ago.
Okay.
See the guy in blue in the middle?
Yes.
That's me.
Yeah, that's he.
Yeah. In the South Sumatra Island, tropical forest, you may meet with various new friends, like tigers, wolves, leeches. During our stay, our team found a few Sumatra tigers and wolves inside. Quite dangerous, you know. And even, you know, my friend was even bitten. I mean, the surveyor. My friend was even bitten by the leeches. Around 8 or 9 leeches.
Leeches.
Yeah, leeches. Not the fruit lychees, but leeches. See, the one in the middle. The one in the middle.
Ew.
Like something like eel, but shorter. It's itchy. It's oily. It's curly. 8 or 9 leeches went inside his trousers quietly when he was doing RTK survey, you know. And then he began to bleed a lot, you know.
Ew.
Oh my God.
Oh, stop. Jackie, it's not funny, okay? But is it true?
Okay. Of course, it's no fun, I'm sure, but it's true. I was not kidding.
Oh.
Anyway, the misfortune was gone because we held them out with our UAV-based LiDAR survey, right? Now everything done with short time, so they don't need to go inside the forest and measure point by point, right? Easier.
Yes.
Yeah. So that's all for the day. I'm sorry we don't have enough time to present every single detail and show you in the live, right? But if you are interested in it, just let us know. And
we will tell you more about our stories.
Yep. We are always ready to share our experience, and we would like to learn about your new topics, your demands, this and that, right? And how about now? Time for Q&A, okay?
Okay.
Thank you.
Questions not just from me. Okay. So the
first one. Thank you for the questions. First one, why not use UAS photogrammetry for this survey job? You know, the client demand 10 centimeter for this survey job, right? 10 centimeter in elevation. It's hard to guarantee in the way of drone mapping. You know, the survey zone is elevated, vegetated, right? It's almost like corridor mapping. Instead of a standard polygon, 23 hectares, right? So it's hard for you to travel here and there. You see, traffic is the big issue there. That's why they need to build the roads, right? Time consuming for the RTK measurements.
okay.
Yeah, without sufficient GCPs, how can you adjust accuracy? Yeah, and then on the other hand, I think UAV-based LiDAR survey will provide us more elements, more raw data for the vectorization. You know, they also demand a vector map. Yeah, just like what I showed you before in the PPT. The accurate DEM and point cloud will help us better in vectorizing the houses and the roads, right? Okay, then the next one. Have you ever tried to measure some checkpoints in the vegetation to verify the accuracy? Measure some checkpoints in the vegetation to verify the accuracy.
Yeah.
Yes, we have. However, it's not wise to do so. You know why? The points we measure in the vegetations might not be exactly the points we got in the laser point cloud. Let's say now we have a vegetation group or maybe bushes here.
Yeah.
Only small gaps inside, right? You go there and you measure the RTK points. Okay, this is a RTK rover, carbon fiber pole. You chop it here. It's a physical act. You got the point directly, right? It's easy.
Yeah.
What if for the laser scans? Maybe no scans there because of the blocks, because of the occlusions.
Yeah.
Right? And then in software comparison, the software will select the nearest point to compare with the point you got here. It's not fair. It's not fair. That's why we always measure the points on the hard surface, hard ground surface, right? Instead of the soil or vegetation, right? Then laser scans there, and then RTK measurements there. It's easy to tell the deviations in comparison.
Yeah.
Yeah. Okay. Next one. Last one.
Yeah.
What's the area size that your processing team can vectorize in a day? Area size to vectorize in a day. So it's about the processing efficiency.
Yeah.
Basically speaking, our data processing center is split into three teams. One for point cloud classification, right, for DEM. One for orthophoto map production. One and the other for vectorized mapping. Say it 5 people in a team. 5 people in a team. For 1 to 1,000 mapping.
Yeah.
In a day, we can finish 20 square kilometers in point cloud classification and DEM. In a day, 20 square kilometers DEM point cloud classification, and then for DOM, 40 square kilometers in a day, and then vector map around maybe 8 to 10 square kilometers. It's more time consuming, more labor intensive, you know. 8 to 10 square kilometers per day for vector map. The data I just presented is for 1 to 1,000 scale. Suppose we do it in 1 to 2,000, it will be a double. It will be a double.
Okay.
But the efficiency is closely related to the vegetational cover, number of buildings, and the terrain conditions. So the more buildings to vectorize, the higher vegetational cover, and the more elevated the zone is, it will take more time for us, right? We need more time to do so, right? So it depends. Let's see what we can do for you, my friends.
Okay.
So
that's all?
Yeah, almost. Let's call it a day. Now is the time. Thank you so much for staying with us here. Have a nice day and take care. Bye-bye.
Bye-bye.